be able to express the electric flux for the uniform electric field and can describe the relation between Gauss theorem and Coulomb's law. Let us see the statement. Electric flux, the total number of electric field lines passing normally through that area. Let us analyze the statement. We can take the key term, that is electric field lines. What is electric field lines? What are the properties? As we know that very well. Past the video, just recall it. You can say that. Yes. It is a continuous curve and it will not intersect each other, and it starts from positive and ends with negative. And by seeing the diagram, you may understand that the number of electric field lines which is passing through that area, the flux which is directly proportional to that. The field line increases, then flux will increase. We may see the next keyword, that is area. If the area increases, the boundary is getting increased, then the flux will also increases. The next one is orientation. What's that? The connection between the flux and the orientation. See, by observing the diagram clearly, you may understand what is the connection between the flux and the orientation. See the first diagram. The electric field lines and the area which is normal to that. The area which is normal to the electric field lines. Then it will create the angle theta which is equal to 0. So cos 0 is 1, then flux will be maximum there. Whereas see the next diagram, the area and as well as the electric field lines are parallel. If parallel means it will create the angle which is 90 degree. So cos 90 which is 0. You may understand more clear with another example, right? In a stream, the amount of water flowing through a ring. Naturally, how you hold the ring? So for example, if you hold the ring normal to the flow of water, you may get the maximum amount of water flow through that. Is it right? Yes. By the above explanation, you may understand that the density of flow, that is the electric field lines, and it may be depending upon the flux may be proportional to the area and the orientation. Yes, you're right. You may notice an ambiguity here. What is the direction of the area element along its normal we said? We know that very well, but the normal points two different directions. Which one we have to choose? Yes. Again, you can pause the video and search the answer. Think about it. Yeah, of course, children. Is it right? Notice an ambiguity here. The direction of area element is along its normal. But normal can point two directions. Then which direction do we choose as the direction of the vector associated with the area element? Just think. Yes. By observing the diagram, you may understand that the vector associated with every area element of a closed surface is taken to be in direction the outward normal. Mathematical relation of flux phi. So phi E which is equal to normal component of E into surface area. So phi E which is equal to E cos theta into del S. So we need total flux through any surface. So phi E which is equal to closed integral over S E dot ds. So phi E which is equal to E dot A. Flux is the scalar quantity, and the SI unit of flux which we have to take the electric field and the surface area. So for the electric field, Newton per Coulomb and meter square. So the SI unit of flux which is Newton meter square Coulomb power -1. Now we'll see Gauss theorem. The statement, the total flux through a closed surface is 1 by epsilon naught times the net charge enclosed by the closed surface. The mathematical relation phi E which is equal to closed integral over S E dot ds which is equal to Q by epsilon naught. Let us see the proof. An isolated point charge Q we can take. Suppose the sphere is the surface and the radius r is centered on the charge Q. Now we will take the sphere is the surface of Gaussian surface. What is Gaussian surface? The term which is very new for us. Yes, the Gaussian surface, which is nothing but, first of all, it is an imaginary surface. And why don't we choose a different types of surfaces? Of course we can choose. We can take any cube or maybe like toroid or any irregular shape we can take it. But it should be an enclosed surface, right? Now here the clever choice of a surface, that is the sphere we have taken, it is very easy to find out the electric field lines produce the charge area, right? We'll see the proof. Electric field, we said, the electric field which is equal in all the place which is there, that is E which is equal to, as per the Coulomb's law, 1 by 4 pi epsilon naught Q by R square. Here you may notice from the diagram, that is the electric field lines which is radially outward, and also the ds, that is area element, is also radially outward. So both are parallel with each other, theta which is equal to 0 degree. Then cos theta which is 1, then we are applying that into the flux, we can get d phi which is equal to closed integral over s E dot ds which is equal to EDS. Then for total flux we need E into the area of the sphere, which is 1 by 4 pi epsilon naught Q by R square into the area of sphere, which is what? Yes, 4 pi R square. By simplifying this, we will get phi E, which is equal to Q by epsilon naught. Application of Gauss law, that is electric field due to the infinitely straight long charged wire, for that the linear charge density is lambda per centimeter. See, the field of the line charge is directed radially outward and its magnitude is same at every point, all the points, and it is equidistant from the line charge. And to determine the field of a distance r from the line charge, we can choose a cylindrical Gaussian surface of radius r, length L, and it is along with its axis. By observing the diagram, you may understand that the curved surface, one curved surface and two flat surfaces. See, the curved surface is parallel to electric field lines, as the two flat surfaces are perpendicular to the field lines. So that we can, the perpendicular to that electric field lines, which is cancel out, then only we can move further with the contributes of the curved surface, only contributes the electric flux. We'll only see the mathematical formula for that. Then applying the electric flux phi E, which is equal to closed integral over S E dot ds. We can take ds1 for that curved surface. So ds2, ds3 automatically it will cancel out because of cos 90 degree. Then integral, closed integral over S E dot ds cos 0, that is ds1. So area of curved surface is what? 2 pi rl. Then phi E, which is equal to E into 2 pi rl. Then here the charge of enclosed by the Gaussian surface Q, which is equal to lambda L. So pi E, that is phi E, which is equal to Q by epsilon naught. We are applying the flux value and the charge, we will get E into 2 pi rl, which is equal to lambda L by epsilon naught. So what is the value for the electric field? E, which is equal to lambda by 2 pi epsilon naught r. Here the electric field is inversely proportional to the distance of the line charge. Let's recap. Now you can click the pause button and recall it. Now we may click the play button. Now the electric flux, the electric field lines, the total number of electric field lines passing normally through that area, phi, which is equal to E vector dot A vector. Gauss theorem, that is phi E, which is equal to Q by epsilon naught, that is the total flux passing through the closed surface is 1 by epsilon naught time the net charge enclosed by the surface, and the SI unit of flux, which is Newton meter square, coulomb per minus 1, and the application, that is the field due to the infinite long straight uniformly charged wire E, which is equal to lambda by 2 pi epsilon naught r, and the electric field is inversely proportional to the distance. Yes, it's time for assessment. We can see one by one questions. Question 1. Careful measurement of the electric field at the surface of a black box indicates that the net outward flux through the surface of the box is 8.0 into 10 power 3 Newton meter square coulomb power minus 1. The question is, what is the net charge inside the flux, and if the net outward flux through the surface is suppose 0, and could you conclude that there were no charge inside the box, and why? Just pass it, think the answer, and now you can play it. For question number 1, the answer is flux phi E, which is equal to Q by epsilon naught. And the subdivision second question, quite interesting, that is, if net outward flux through the surface is suppose 0, we cannot say that the charge is 0. That is, the net charge inside the body may be 0, right? That means what? The positive and the negative charges was equal amount of charges which is there. So there is no net flux on it. Yes, children, you understand that from this session about electric flux, Gauss law, and how it relate with the Coulomb's law, all those things, and the application of Gauss theorem, you may understand that, right? Thank you, students.